This is the inverse functions tutorial. Composite inverse functions. There's a general formula for composite inverse functions, and that is the inverse of g times g of x is equal to x, and vice versa, g of x times the inverse of g of x is equal to x, if and only if f and f to the negative 1 are inverse functions. So, to break that down into layman's terms, what that essentially means is if a function and its inverse are multiplied together, they'll negate each other, and what you'll end up with is x. You're only going to end up with x alone by itself if they are inversely related, those two functions. So let's go over an example and I'll show you what I mean by that. In this example, we'd like to determine if the given functions are inverses of each other. So here's our f of x and our f negative 1 of x, so our f inverse. So in order to determine whether or not f of x and f of negative 1 of x are inverses, we could multiply them together, and it should just negate itself, and we should arrive at x. There's also another easy way to do this. F of x equals x squared plus 5 can be rewritten as y is equal to x squared plus 5. I've just turned the f of x into y. And in order to find the inverse of this function, what you want to do is switch the variables x and y. So you'd have x is equal to y squared plus 5. Now, to find the inverse, you want to solve this new function right here for y again. You want to get y alone on one side of the equation, so I'll do that work over here. We have x is equal to y squared plus 5, so the first thing you want to do is subtract 5 from both sides of the equation. And you'll have x minus 5 on the left is equal to y squared. Now, you want to get rid of that squared attached to the y, so I'm going to take the square root of both sides of the equation. So on the left-hand side of the equation, you're going to have positive or negative the square root of x minus 5, and on the right-hand side of the equation, you're going to have y alone because the square root and the square canceled each other out. And so you could rewrite that. We're going to take that, get rid of the y now, and we're just going to call it the inverse of x. Because like we said originally, by switching the x and y and solving again for y, we're finding the inverse of that original function. Now, is this inverse that we've just created, is that equal to this inverse that they provided in the question? Well, no, because the inverse that they provided is positive or negative square root of x plus 5, and we have x minus 5 under the root. So these two functions are not the inverse of each other. Now that we've seen a little bit about how to determine if they're inverses of each other, let's look at graphing inverse functions. In order to graph the inverse of a function, you must switch the x and y coordinates of the original function. So, for an example, if the original points of the graph of a function, if one of those points happened to be 3, 2, so the x was 3 and the y was 2, then you would switch the x and the y coordinates for the inverse point, and you'd get, this would be your x still, and the 3 would be your y. So the x and y stay in position, but you actually just flip the numbers. So the domain and range then flip when dealing with the inverse of a function. The domain of a function g becomes the range of function inverse g, and the range of function g becomes the domain of function inverse g. So the domain and range, the values stay the same, but they actually switch when you're going from a function to its inverse. So the domain of one becomes the range of the other, and the range of that one becomes the domain of the other. Let's take a look at a problem and I'll show you that. So our problem is going to be to graph this relation and graph its inverse. So the first thing I want to do is come up with the inverse of that relation. I'll go ahead and put a graph in here and we'll use that in just a minute or two. So this is our original function, and it could be f of x is equal to 4x minus 2, or g of x, or h of x, whatever you want to call it. Over here, I'm going to write its inverse. I'll call this original one f of x, and this guy over here is going to be the f inverse of x. And to find out what the inverse is, our original function is y is equal to 4x minus 2. And like we did previously, we're going to switch the position of the x and y. So x is equal to 4 times y minus 2. Now I'll add 2 to both sides of the equation, and we'll get x plus 2 is equal to 4 times y, because the negative 2 and positive 2 canceled on the right here. Now we want to divide by 4 on both sides of the equation to get y alone. And we'll have x plus 2 over 4 is equal to y. So that becomes our inverse function. Y, f of negative 1x, is x plus 2 over 4. So we want to graph the relation, and we want to graph its inverse. In order to graph it, let's just construct an x and y chart and plot some points. Now, you can obviously use a graphing calculator to do this, but I'm going to show you how to do it without a graphing calculator, because some of these functions and their inverses actually become pretty difficult to put into a calculator. For the original relation, we're just going to plot these points: negative 2, negative 1, 0, 1, and 2. So if you were to plug negative 2 into this x value, you'd have 4 times negative 2, which is negative 8, minus 2, which is negative 10. So that would be your y value. Negative 1, if you plugged it in, would be 4 times negative 1, which is negative 4, minus 2, which is negative 6. 0, if you plugged it in, would be 4 times 0, which is 0, minus 2. So negative 2 would be your answer. You'll see a pattern that they seem to be increasing by positive 4 each time for your y value, which makes this 2 and this 6. Now remember what we said in the beginning of the tutorial, that when graphing this function, the x and y values, their numbers are actually just going to switch when you're graphing the inverse of a function. So you're just going to take those same points, but now the negative 2, negative 1, 0, 1, and 2 are going to be over here on the y-coordinate, and negative 10, negative 6, negative 2, 2, and 6 are going to be here. And if you don't believe me, let's plug one in. Why don't we plug in 6 for this x-coordinate right here? 6 plus 2 is 8, and 8 divided by 4 is 2. It's going to work with every one of these coordinate points, because we know that we have that function correct. So now let's just go ahead and graph them. I'll graph the original function in this same color, and I'll graph the inverse function in blue. So let's plot these points, negative 2 and negative 10. So I'll go negative 2 to the left of the origin and 10 down and put a point. For the next point, I'll go 1 to the left of the origin and 6 down and plot a point. Then at the origin and 2 down, then 1 and 2 up, then 2 and 6 up. And I'll go ahead and draw a line to connect those points. So there's our line. Now let's graph our inverse, and I'm going to graph this one in blue. So our first point occurs at negative 10, negative 2. So I'll go 10 to the left and 2 down and plot a point. Our next coordinate point is negative 6, negative 1. So I'll go 6 to the left and 1 down, then negative 2 and 0, 2 and 1, and 6 and 2. And I'll draw a line in here to connect those points. So if you wanted, you could just label the graph. This is our f of x function graphed, and this guy here is our inverse function graphed. That's how you graph functions and their inverse. Now also, remember when dealing with this function and its inverse that the domain and range of the original function are inverted. So the domain of the original function f of x is now the range of the inverse function, and the range of the original function is the domain of the inverse function. Now in both of these functions, if the function and its inverse, our domain and range were all real numbers, so that's going to stay the same. However, just keep that in mind, that the domain of the regular function is the range of its inverse, and the range of the original function is the domain of its inverse.